Hi everybody, I'm Adrian Martinez with 3dguru.online. Welcome to the first in a series of videos about Autodesk Fusion 360. Today's video will be an introduction to Fusion 360. There are a couple basic system requirements. You need to make sure that your computer has Mavericks or Windows 7 or above installed. You have a 64-bit processor. I don't think Fusion will even install on 32-bit processors now. 3 gigs of RAM or more, and really the more the better. The machine that I'm using right now has got 16 gigs of RAM. An internet connection, approximately 2.5 gigs disk space, and this one's an important one. The performance of Fusion 360 is greatly enhanced if you have a graphical processing unit or a GPU. It will work on computers that have onboard graphics like the Intel type graphics, but you'll see things like the cursor or drawing objects lagging behind the cursor on machines that are don't have GPUs, and so it's definitely better to have like a good gaming machine to run this on. And finally, you need to make sure that you have a Microsoft compliant mouse. I really do recommend going with the Microsoft like 3-button mouse or better that has like a wheel because it really, Fusion 360 is really optimized for drawing with that particular type of input device, and you'll see a lot more about that when we get a little bit further along. There are specific functions where you'll need to push down on the wheel and then zoom in and zoom out with the wheel, and it's again much more easy to do if you have that kind of a mouse. Okay, in preparation for this class, you need to make sure you go to Autodesk.com and download Fusion 360, and then follow the prompts to register the software as a hobbyist or enthusiast. That's one of the things that's really great about Fusion, that it's giving you the full featured application with no limitations. And for students, enthusiasts, hobbyists, and startup, there's no fee. So it's really, really a great application, and it's wonderful that Autodesk is making it available to us, makers, designers, amateur hobbyists, and everything like that to do some really amazing things with it. So what are the learning outcomes for today? We're going to discover Fusion 360's basic capabilities. We're going to learn and understand about its interface and toolbar. We're going to plan how to turn an idea into an object. This is an important part of creating something, and it's really not anything to do with Fusion 360 per se, but taking a sketch on paper, writing some things down, fasteners, how things fit together, so you have kind of a good plan before you start drawing in Fusion. We're going to create a 2D sketch. We're going to learn a little bit about 2D basic drawing tools. We're going to complete the drawing. We're going to talk a little bit about the 3D design tools, the entry-level 3D design tools. We're going to turn the 2D drawing into an object. We're going to modify that object. And then finally, we're going to save it as an STL file so that you could import it in your favorite slicer, slice it, and then 3D print it. The whole objective of today's class is to enable you to be able to design the things that you need. So you're not limited to whatever STL files you can find commonly online. You'll be able to actually generate exactly what you want to fit exactly how you need it to and look exactly how you want it to. And that's one of the things that's really great about Fusion 360, because it empowers us to easily make those sort of things. So we're going to take a minute and talk about the user interface and toolbar here before we go into Fusion itself. The first thing we want to talk about is a data panel. That's in this area in box number 1. The data panel is essentially your kind of master folder where you're going to keep all of your drawings. You can create folders in there. You can identify them as high-level projects with folders inside them, and then you have the individual files that are in there. There's some additional functionality in there about sharing and everything like that, but we're going to save that for another video. We have the data panel toggle, file, save, undo, and redo buttons, and those appear in the top of the screen in box number 2 here. The little thing that looks like a Rubik's Cube, that will allow you to hide and display the data panel here in order to get a little bit more drawing space. The page gives you the ability to create new drawings and then save them as different file names so that you can kind of split, a drawing that you've taken to a certain point and then you want to go somewhere else with it without disturbing the original drawing. Obviously our save icon and our undo and redo buttons. Our toolbar appears in box number 3. Today we're going to be working in a modeling environment, primarily with the sketch tools and in these basic 3D modeling tools under the create and the modify dropdowns. Profile and help is in box number 4. This will identify your name, and then by clicking on that, it'll give you access to preferences where you can change Fusion 360's behavior. The help button with the little question mark leads to a drop-down, and one of the most valuable things there is a community forum. You can click on that. It's a heavily moderated forum. It's a professional business forum, so you're not going to run into 12-year-olds there calling you a noob because you don't know how to do a revolve or something like that. It's a really great message board forum where you can go online, post a question, and get answers pretty quickly. Next, we have our view cube here in box number 5. This gives you the ability to click on different areas and edges of the cube so you can snap to some standard orientations. You can also click on it and drag it around in order to orbit around the object that you're drawing. The browser appears in box number 6 here, and not a lot of information in here right now because this is a blank drawing, but as you create sketches, as you create 3D bodies, save components, this list will grow, and it'll give you the ability to toggle the visibility of these bodies on and off, so it makes it easier to design things when you hide certain things, and then you can look at it all together later, whenever you like. There's a lot of functions you can do there. Next, we're going to look at our timeline. The timeline, again, not a lot of information down here, but as you begin drawing, you'll notice that sketches will appear here, lofts, radiuses, fillets, any discrete function or thing that you do to your drawing is going to appear here, and it's going to give you the ability to kind of slide forward and backwards, almost like scrubbing in a video, to look at different stages of your drawing. And for example, if you kind of don't like the way something's gone and you've gone too far down a path that hitting the undo button like 50 times is not necessarily the most efficient way to get to something, you can actually drag the slider here and then kind of pull it back to the point in your timeline where you're happy with where the drawing was before you've kind of went down a path that you didn't like, and you can delete everything after that point. Interesting thing though, you want to make sure you don't go too far back in the timeline and make changes to things because that can break some associations and some constraints that are in Fusion that helps Fusion to understand what you want to do. This will kind of show you a little bit of the sci-fi geek that's in me here, but every movie you've ever seen where someone's gone back in time and messed with the future or messed with the past and caused some really negative consequences, you're going to really experience those in real life if you try to do that here in Fusion. So there's a really limited number of things that you'll be able to do in the past of your timeline where it'll end up with good things happening in the future. So just definitely create new sketches wherever you're at in the timeline instead of kind of going back to old sketches, because everything that happens after a sketch, for example, depends on the dependencies and everything else that's in there. So if you go changing things, it makes it really difficult for Fusion to kind of infer what you really want to have happen on the things that have happened after that. So anyway, it all makes sense in a minute once we get into Fusion and start talking about that. All right, then we have our navigation bar and display settings. It's in box number 8 here. I don't really use this too often. There's a function called look at that we'll talk about a little bit later on in the video. But the rest of these functions are really just accessible through the mouse and the zoom wheel and everything else like that. And it's generally I don't really do much with that. I mean, I've been working with Fusion for about 3 years now. I very, very rarely click in this area. All right, so let's take a minute to plan how we turn an idea into a project. Kind of selected this drawing here because it's a good representation of kind of what you should have. It doesn't necessarily have to be this nice. Obviously, the person who generated this is really talented, but you can see things like, there's an insert that goes into the handles of the scissors. There's this little path down here where the designer is kind of trying to convey how the fastener that holds the two halves of the scissors together, how it goes together, how the handle insert goes into the outer part of the handle, how they lock into each other, kind of how the blades kind of go past each other and everything like that. There's notes, there's arrow pointers that kind of describe some things, and having this kind of information really, really does help, quite a bit. So it's important to have sketches and notes to refer to when you're drawing for things like dimensions, how things fit together. If you're going to be reverse engineering something like, for example, let's say you have a flight controller for a quadcopter and you're trying to make an enclosure for it, or you want to contribute to the millions of Raspberry Pi cases that are out available in the world today, but you got to have your own spin on it. Measuring the distance, around your circuit board on your Raspberry Pi to the different ports. I consider that kind of like reverse engineering a box. You're measuring where things are, getting dimensions so that when you draw something, your circuit board or whatever you're making is going to fit in there properly. You want to draw a basic paper sketch and then add some reference notes to it so you know what you're wanting to accomplish. And having that on hand really saves a lot of time and kind of prevents you from painting yourself into corners, or helps to make sure that what your end result is really exactly what you want. So let's take a second and look at a paper sketch of what we're going to be building today. Obviously, nowhere near the quality of what we were doing before, but this is really all you need. So today, this video is going to guide you through the process of creating a 50mm cube project box. So I started by just drawing a cube and kind of throwing some dimensions on here. So it's 50mm tall, 50mm deep, 50mm wide. Over here on the right, you see like a top view of the box. And I've kind of said, I like the dimension of 3mm for the wall thickness here. If the box is 50mm on the outside dimensions and we have a 3mm wall thickness, that means that you're going to have a 44mm opening inside the box. Okay, so if we have a 3mm wall and we're going to put a lid on this box, it kind of stands to reason that the lid should be 3mm thick. And if you want to end up with a total stack dimension of 50mm, that means that the box has to be 47mm tall if the lid is 3. Now, think about that. If you didn't really kind of think through that before you got started, it would be very easy to make a 50 by 50 by 53mm box if you made your box 53mm tall and then you added a 3mm lid on top of that. Sometimes, it really make no difference, but if the goal is to make something that's exactly 50mm cubed to, I don't know, fit inside a cubby, you're keeping resistors or something like that for storage or something like that inside this box. If you don't keep that in mind as you're drawing it, you could end up with something that doesn't fit into something else. So again, that's one of the reasons why having these notes is really, really valuable. Another thing that's important is you got to think about what you're trying to put inside it. So we're doing a 50mm cube box. That means that basically whatever's going to go inside this has got to be 44mm cubed or smaller because of the size of the walls. Make sure you keep that in mind. So if you're going to make something and you want to enclose it in like a project box like this, measure the object and make sure you understand the dimensions. Add a little bit of extra clearance to allow you to get the object in and out of it easily. And again, those things will really help you out. Another thing you want to keep in mind is how things fit into each other. So let's say this is our lid down here. We know the opening of the box is 44mm. If we made a projection or a boss that stuck up out of the lid to locate the lid onto the box, and it was 44mm, you'd have a heck of a time pushing that in there because you're wanting the boss to occupy the same space as the walls. It'd just be way too tight. You might be able to smash it on there, but good luck getting that lid off there again. So what we want to do, and just based on experience, you could Google this and kind of get other people's thoughts on it, but I found that if you make the boss or the thing that inserts into some other 3D printed part about a 0.5 millimeter smaller in every axis, it's going to fit in well. It'll be snug. It'll stay put for the most part, but it'll be able to easily come on and off. So we want to make sure that the raised area on a lid, when it inserts into the box, is about 43 millimeters in all directions. Another thing I'm pointing out is, we want to make sure we have a way of maybe securing the lid, not just pressing it on. So you want to think about what kind of fasteners you're going to use. In this case, since we're doing a metric box, it's 50 millimeters, an M3 screw is really a good size to use, right? So I kind of drew this little representation of a button head M3 screw. And when you say, okay, I want to do a screw like this, you got to think about what size holes you're going to put in your part so the screw can kind of form threads into it. It'll actually like self-tap into it. Or in another part like the lid, you want to make sure that the screw goes through it with little to no resistance. So, you're not threading it into the lid and threading it into the part and maybe not getting things to square up and line up the way you want. So you got to think about how big the screw is as far as its, diameter, and then how big a hole you want to use so that it can actually self-tap into it. And that's really the concept of the major diameter and minor diameter of a screw. If you go online and you Google M3 screw major diameter, what you're going to get is the distance of the screw come from the peak to the peaks of the threads, and that's the overall diameter of the screw. And for an M3 screw, that's about 3 millimeters. Now, the minor diameter represents kind of the bottom trough of each one of the threads, and then how, what that distance would be. Or if you were to somehow strip all the threads off of the screw, how big would the shank at the center of the screw be? And that's 2.79 millimeters. Again, I Googled that dimension so I would understand that. So if you're going to make a hole for this screw to thread into, the very smallest hole that it could thread into successfully would be about 2.79 or 2.8 millimeters in diameter. That'd be a very tight fit though. To make it go in a little bit easier and still have secure threads, I decided to use a 2.9 millimeter dimension for the box. And then again, that'll give a good amount of bite for the threads, but still make the screw relatively easy to get in and out. And for the lid, in order to let the screw pass through easily, I decided to make that a 3.5 millimeter dimension. And in drawing the dimensions in here, writing them down and kind of drawing some arrows so you can understand where they go is really helpful. And again, will go a long way to make sure that the results you achieve are what you're really envisioning when you start your project. Okay, so let's review a little bit about what we're going to do in the next few minutes, and then we'll actually get into Fusion and draw our project box. This whole video is about you following along. So in order for you to be most successful, you're going to follow along doing what I'm doing. Hit pause after you've heard what I had to say, and then complete the steps, and then go back to the video, watch what the next step is, and then kind of follow along. And when we're done, we're going to end up with an STL file that you can pop in your slicer, slice, and then actually print, pretty much immediately. All right, so the first thing we're going to do is we're going to do a two-dimensional drawing. We're going to review our basic 2D drawing tools. We're going to complete a 2D drawing, and then we're going to turn it into a 3D object. We're going to discuss the 3D design tools. We're going to turn that 2D drawing into a 3D object, and we're going to do a couple things to modify it and really kind of mess around with it a little bit to show you some different things that you can do once it's actually a 3D object. And then finally, we're going to save the object as an STL file, checking dimensions and orientation, and eventually, we're not going to print the object, but you'll be ready to print the object at that point in time. Okay, so we're going to take a minute. We're going to jump over into Fusion. All right, and then this is the basic screen that you'll see when you jump online to Fusion. Obviously, I've got some things over here on the left, and if any of you guys know some of my work in the past, you'll see that these are actually some parts from the Hypercube Core XY 300 remix of Tech2C's Hypercube Core XY 3D printer. And again, these are all the files for the drawing, like the overall assembled printer, a lot of different things. And all of these things that I did here really just build on the core of what you're learning about right now. So it's actually, looks like it's complicated to do a lot of these things, but with just a little bit of practice, you'll be able to do these sort of things in no time. All right, so what I'm going to do is toggle close this data panel by clicking the hide data panel icon. And we're going to go ahead and just take a second to kind of review a couple things. We have our show data panel, we have our file icon, which gives you the ability to create new designs, the save icon, our undo and our redo buttons. Over here, we have your profile information. And if you'd go ahead and click on that, I want to make one quick change here. First, if you look here, you'll notice that on my view icon or my view cube, I have Z going up. Now, if you've just installed Fusion, chances are that is not how yours is going to set up. So I want to take a second to explain why you'd want to change that and then show you how to change that. First thing I want to do is explain kind of why this is important. Now, by default, the system has Y pointing up, and that's kind of what graphical design is on computers. A lot of applications that you do that kind of default to Y being up. But when it comes to actually making things in the real world, when you go to a machine shop and you're milling something, or when you're talking about a 3D printer, Z is the vertical dimension, Y is the front and back dimension, and X is the kind of the left to right, side to side dimension. And in order to be consistent, it really is helpful to go ahead and make that change. So if you click on your name and click on Preferences, right about the middle, there'll be a drop-down box. Go ahead and change that from Y up to Z up, and then click OK. Now, if you had a drawing already started, it will probably still say Y up. In order to have that change, you're going to want to go ahead and close out or click the X to get out of the drawing you were at, and click, don't save if it comes up. And as soon as it refreshes, you'll see that this has changed to Z up. Okay? The next thing you're going to want to look at before you get started, since this particular drawing is going to be using the metric system, we want to make sure that we're in that setting. You're going to click on the little triangle next to Document Settings where it says Units. Verify that it says millimeters. If it doesn't, click on a little page for changing the active units. Click the unit type drop down and select millimeters, and then click OK. Mine's already there, so I'm just going to go ahead and click Cancel. All right. Now, when you look at my toolbar, you'll notice that there's a whole bunch of stuff up here. These are some tools that I've decided to kind of add here in order to make them more accessible. Now, you can always add or remove tools just by grabbing them and kind of dropping them into the space. This doesn't delete anything, it just kind of pulls them off of the toolbar. If you want to put tools up there, click on the sketch drop-down, hover over a specific tool type, and you'll notice there's an upswept arrow. That upswept arrow will allow you to add that to the toolbar. Now, there are a couple tools that I think are very valuable. By default, you're going to have sketch and you're going to have line. But I'm also going to add rectangle, both the center rectangle, and again, I'm going to click that upswept arrow, and I'm also going to click the 2-point rectangle. Those are two different types of rectangles that I use very commonly when I draw. When I draw circles, I almost always use a center diameter circle. So I'm going to click the upswept arrow and add that one to my toolbar. I very, very commonly use the trim command, the extend command, the offset command, and the mirror command. And that kind of gets me back to where I was when we were starting here. And we're going to use all of essentially almost every one of these tools today. All right, so let's go ahead and start a sketch. You're going to hover over the Create Sketch icon, click on it, and then you'll have this set of flags that pop up, and then these are basically your origin points. And if you look at them, each plane on the origin is kind of aligned with your view cube. So you have a front plane, you have your left and right plane, you have a bottom plane. And for the purposes of today's class, we want to select this one here at the bottom, right? And when you click on it, it'll rotate around so it's flat and facing you. And you should see the word top appear on your view cube, along with a toolbox called the sketch palette appear. All right. Next thing you're going to do is click on the center rectangle tool. When you click on it, it'll highlight the tool blue, which will indicate that it's active. And you'll notice next to my cursor, you'll have a center rectangle icon that appears. And what it's telling you is you want to place your cursor on the center point. To do that, just hover over whatever you want to start. We're going to start on the origin of our center point of our drawing. And you'll notice that as I do that, a little blue square appears, and that is kind of a snap indicator that you're definitely going to be on the center if you click on this now. So now left click just one time and pull up and to the right, just any distance. You'll see that the rectangle starts to appear, and you'll have a couple of dimension indicators, and one of them is going to be highlighted. Now it's very difficult to hit a specific dimension just by clicking on or just by dragging. It's just a very fine level of detail and numbers after the decimal here. So it's easier to just go ahead and type it in. So if you type on your keypad on your screen, it's going to enter the numbers on a highlighted dimension field. And I'm going to go ahead and type in 50. Okay. Then I'll hit my tab key on my keyboard to bring me over to the other dimension. And I'm also going to type in 50 there. And now we have exactly what we're looking for. So hit your enter key and it'll lock that in. I'm going to take a moment to describe a little bit about what these dimension flags do. They're not just simple indicators. They give you the ability to actually change the dimensions if you like. So for example, if I hit 100 by clicking on it, it now gives me a 100 by 50 millimeter box. If I want to change that back, I just double click on it again, enter 50. It's also capable of doing some basic arithmetic too. Like for example, let's say that you needed to find the center of some dimension, or you wanted to put a box there, and I wanted to take 50 millimeters divided by 2. Obviously that's easy to figure out, but if you had a much larger number or some crazy decimal or something like that, it would be much more difficult to figure out. So if I divide by 2 and I hit enter, now it's giving me a 25 millimeter dimension there. And again, you can add, subtract, divide, and multiply in there. I'm going to go ahead and double click on it, change it to 50, and hit enter to bring it back. Sometimes when you're drawing, if you're using and entering dimensions like this, your drawing could get cluttered with a lot of these dimension flags. You can always just click on them and hit your delete key to get rid of them. And if you want to bring them back, you got a couple ways to do that. You can click on your sketch drop down and click on the sketch dimension tool. Click on the line that you want a dimension for, pull it out, and then click where you want it to be, hit enter, and you've brought the tool back. Now, if you want to disable any tool, like you see my cursor now has the sketch dimension icon appearing next to it. So if I click on anything else, it's just going to do that again. You can hit the escape key to get out of it. Okay. Now, if you noticed, when I click the sketch drop down, there'll be a letter next to some of the different functions, and D is one of them for sketch dimension. That means that the letter D is a hotkey to activate that tool. So if I hit the letter D, it automatically adds the sketch dimension function. I can click on a line, pull a dimension down, hit enter, and the dimension is back. And of course, just like before, hit escape to remove that function from your cursor. I'm going to go ahead and delete these because I really just don't need them anymore now that I got the dimensions exactly how I want. Okay, to navigate around your drawing space, if you use the wheel on your mouse, you can roll the wheel one direction to zoom in and roll the wheel the other direction to zoom out. That's one of the ways I get around my drawings. Now, if you put your cursor over a specific area and zoom in, it'll actually go exactly where your cursor is going. So go ahead and practice that. Kind of zoom into the corners of your cube and then zoom back out. Anywhere you put the cursor, it's going to let you zoom in and out of that specific area. Another thing you can do is actually push down on your wheel, and by pushing down on your wheel, it gives you the ability to kind of pan and pull your drawing anywhere you want it to be. You can also hold your shift key down and then push down on the wheel of your mouse, and that will activate the orbit command so that you can kind of orbit around your drawing and do some different things. It doesn't really look like much right now because it's just a two-dimensional object, and basically it almost disappears when you turn it sideways. But that's how you orbit around. We're going to work with that a little bit more. You can also orbit around by clicking on your view cube and rotating it around. If you've tried this out, go ahead and click the word top, and it'll snap you to a perfect kind of orthogonal view of the top of your drawing surface. You may notice there are some little marks that appear in various points around your drawing, and these are called constraint indicators. The constraint indicators indicate that For example, this line will forever be parallel to a line that's right next to it, like this one right over here. And then this line is parallel to this line. And then this particular constraint means that this is always going to be a perpendicular relationship. And these are all different constraints. You can hide them by clicking the Show Constraints checkbox off, and you can bring them back just by clicking it on. Sometimes after you've drawn a drawing with a lot of lines and a lot of complexity in a sketch, it'll get a little bit cluttered, so you can turn the constraints off to do that. All right, next thing we're going to do is offset some lines in order to give ourselves that kind of 3mm wall thickness that we were looking for in our sketch that we did initially. So we have the offset command, and if you notice, offset is activated by the letter O. So you can either click here or hit the O hotkey in order to activate that tool. So we're going to click on it. You'll see the tool's highlighted, and then you have a toolbox that appears that gives you some different functions. And really the only choice for offset is whether you want to chain the selection or not. When the chain selection checkbox is checked and you click on any geometry, it's going to highlight or select all lines associated with it. And then you can offset to the outside of your box or to the inside of your box. Now, to unselect this, you can either hit the escape key or click the X next to the sketch curve selection, and that'll deselect it. If you uncheck chain selection, now if you click on a line, it'll just move one specific line. And obviously there'll be times when you want to do that with a specific line. There'll be other times when you want to do it with all lines. So I'm going to unselect this. We're going to recheck the chain selection box so we can select all lines. And we're going to grab the handlebar, the slider for this, and we're going to pull that in. You notice that the number, the way that I've got this set up, is negative. But when you initially started this square, if you pulled in any direction other than right and up, it might have this number appear to be positive, but it doesn't really matter. Pull the line to the inside, and then whether it's negative or positive, enter a 3, so that you have your lines offset to the inside of your 50mm box. And once that, you can hit enter or click OK to lock that in. The next thing we're going to want to do is locate some holes here for our screws to go into. Now, don't follow along at this point because we want to just want to demonstrate something real quick. But I'm going to click my circle tool, click on a vertex, and then put in like a 3mm opening here, or a circle. And you'll notice that around the walls it gets a little bit thin here. And really to have good strong walls, to prevent the walls from like bulging or turning white, the plastic can sometimes turn white if it's stressed. When you thread a screw in, you want to kind of just make sure you have a consistent 3mm wall. So you definitely don't want to locate your screw here. So I'm going to hit escape. What we're going to want to do next is kind of offset one of these lines half the diameter of a screw, or 1.5mm, to have a place to anchor our center, our circle here. Now there's a couple different ways to do it. We're going to demonstrate it 2 ways. You can hit offset and offset this line negative 1.5mm, but okay, looks like we have a little bit of a warning coming up here. It says one or more of the selected curves has already been offset. Consider offsetting the original profile again instead. Now Fusion's being a little bit cheeky here because it's saying consider, but it's not really giving you any option. The OK button is grayed out and the enter button will do nothing. So I kind of wanted to demonstrate this on purpose. The reason why this is happening is because in order for Fusion to be able to infer what you want to have happen as more and more advanced functions occur as this drawing evolves, it needs you to basically base every drawing or every object from kind of an original line or an original geometry. And by kind of stacking up from that, it really helps Fusion to understand kind of where you want to end up. So to get out of this, again, you either hit escape or the little X key or the X button next to sketch curves, and go ahead and click the original geometry. We're going to pull that down, And we know that, obviously we want this to be about 4.5 millimeters, or negative 4.5 millimeters in this instance. So negative 4.5. And we're only doing that, again, to kind of create the geometry here right in the corner so that we can attach a circle there. So we click our center diameter circle. We hover over the vertex of that point there. And if we look back at our sketch, this is our box. So in order for an M3 screw to kind of form threads, we want this to be 2.9 millimeters. Hit 2.9, hit enter again, and it'll lock that in. At this point, we no longer need this. So you can delete any line or any geometry by clicking the line and hitting delete, or double clicking it. That'll highlight every line that's connected, and then hitting delete. That makes it go away. Now that's one way of drawing a circle and kind of attaching it where you want it to be. The other way you can do it is by clicking sketch, circle, and then using a 3 tangent circle. And I'll explain how that works in a second here. So you click 3 tangent circle, you're going to click one line, another line, and enter 3. Okay, another way you can draw a circle is by clicking on sketch, circle, and selecting a 2 tangent circle. So we're going to click on one line, click on the other line, and then in order to set the diameter, you will make that 2.9 and hit enter. And hit enter again to lock it in. Oops, I'm sorry. Okay, now another way of kind of nesting a circle in a corner is by clicking your sketch drop down, going to circle, and selecting a 2 tangent circle. Then you're going to click the first line you want the circle to be tangent to, the second line you want the circle to be tangent to, and in this case it's not a diameter circle, it's a radius circle. So if the diameter that you want is 2.9 millimeters, you can hit 2.9 divided by 2, hit enter again to lock it in, and now you have a circle placed exactly, right in the corner. This is actually the most precise way of doing it. This actually gives you a little bit of a gap. Now there will be times and places where one is better than the other, but in this particular case, because the screw actually is 3 millimeters in diameter, I actually do want this circle to have a little bit of space like this here, because essentially that is where the threads are going to be going, or they're going to be forming. So I'm going to go ahead and take this guy and I'm going to delete that one. Now at this moment you have kind of an opening in space. So you have walls here, and then you have essentially the shank of a screw right here, but there's nothing around it for it to thread into. In order to make that, you can click your offset tool, click on the circle that you just created, and then enter 3 millimeters to give you a 3 millimeter thick wall around that screw. And you can go ahead and hit enter. All right. Now we've got some lines here. Now pretty soon we're going to be lofting this, and if we do that, you're going to need to do something like clicking on these spaces, and in order to get what you want, you're going to have to hold the shift key, click in the first place, click in the next place, click in another place in order to kind of grab everything that you need, and that's kind of a little bit time consuming. You don't want to have to do that every time, and if you're doing something that's very intricate, sometimes it's easy to miss a certain spot, and you'll end up with holes inside the middle of your object, and that's not really a good thing to do. So I really do recommend using the trim command right here, or the hotkey T on your keyboard, to trim some areas that you don't need. And now when the trim command is activated and you see the trim icon next to your cursor, anything you hover over will give you a preview of what's going to be trimmed or deleted. So I'm going to trim this line here. I'm going to trim this line, and this line. Oops. Let's use our undo. Click it twice to make that happen. Activate your trim command again, and then hover over the line that you do want to trim. There we go. Now we've done that, I'm going to hit the escape key, and I'm going to hover over this space. You see that this is kind of more along the lines of what the wall of our parts box should actually look like. Okay? Now I've done it one time. You could just go ahead and do and repeat these steps, in all the other corners, but we actually have some tools that really help you along with that. And the tool that will really kind of do this for you most quickly can be accessed by clicking on the sketch dropdown, clicking on circular pattern, and you have the circular pattern box come up here. You're going to want to identify the objects that you want to make a circular pattern out of first. And what we're going to do is this little curve here and then the actual circle. If you have a hard time clicking on those, you can zoom way in. Zoom is your friend in this respect, because sometimes what will happen is you might accidentally just click the little point at the center, and that will really just give you a point, and that's really not particularly valuable. So you just want to make sure you have the circle and then the little curve on the outside here for the boss identified. Next thing you're going to do is click the center point tab and then define where you want the center of it to be. And since we started drawing this object with the origin point at the center, it makes it really easy. Click on that. And what you'll see now is that we have a total of 3, a quantity of 3 repeats of the object. You have the original and then these other 2. The default setting from Fusion is always to give you 3 of something. So we're going to change that. As you can see, the highlight on the cursor is right here for 3 for the quantity. And we're going to make that 4. And as you see, it's now kind of nested in the corners exactly where you want them to be. Go ahead and click Enter or OK. And then take a second to activate your trim tool and delete the lines that you no longer need. All right. Now, for all intents and purposes, we've completed drawing our box. So I'm going to hit the escape key to get out of it, and next thing we're going to do is draw the lid. Now we could just do this whole process again and draw the lid, but again, similar to the circular pattern, we have some tools available to us to quickly do that. And what I'm going to suggest you do is you pick some area in space. Make sure that over here in your selection box you have window selection activated. And then again, hover in space away from your box, left click, drag across your drawing, and then let go. That highlights everything. Once you've highlighted everything, right click, and you'll see that there is a copy option. Click copy. Once you've clicked copy, click anywhere out in space to deselect the item, right click again, and you'll see that there's a paste option. When you click paste, you'll see everything is highlighted and these handlebars will appear. These handlebars are used to move your object around. Now they all serve different functions, and we're going to kind of save those discussions for a later point, some other videos. And we'll talk a little bit more about move towards the end of this video, but for our purposes right now, we're going to grab the arrow that points to the right, click on it with your left mouse button, and then drag it to the right any distance so it's clear of your original drawing. And once you're there, just let go of it and click OK. What we've done now is created a copy of that initial drawing that we did. Very nice and quick and easy. Now, if we look back at the sketch that we initially did, we remembered that we needed to have this area be a little bit smaller so that when this lid gets placed on top of the box into this space, that it slides in there easily. To do that, we're going to use the offset tool. We're going to zoom in, click on this geometry. We're going to pull that in -0.5 millimeters. Okay. Now, again, if you created this drawing by pulling the box away in the very first step, in order to achieve this, it might be positive, but again, it doesn't matter. What you want to have is a line offset to the inside of the original geometry by 1/2 millimeter. I'm going to go ahead and hit enter. Once I've done that, I no longer need this geometry on the outside, so I'm going to double click on this. I'm going to hit the delete key to make that go away. All right. Now we're ready to start lofting this and turning it into a 3D object. So first thing we're going to do is we're going to, like before, select the entire object on the left, which we're going to consider our box. Oh, I'm sorry, I forgot one thing. We made a copy here, okay? So the circles here are 2.9 millimeters, and they're the same over here. If we were to just go ahead and continue on without making this change, it would what do you call it? Make it so the actual screw would thread into this too. So what we're going to do is we're going to click on this. We're going to change that to 3.5 and hit enter. So now that screw is the right, or that opening is the right size for the screw to pass through. We're going to kind of delete the other ones that we don't need. We're going to sketch circular pattern. We're going to select a circle that is now 3.5 millimeters. We're going to select the center point of our lid, change the quantity to 4, and click OK. And now it's the right size for the lid. You can see kind of visually the size difference between the two. Okay, now that we've got that done, let's hover away from the initial drawing that we're going to consider our box, drag across it to select everything, right click, and instead of selecting copy this time, we're going to use this tool here called press pull. And press pull gives you the ability to loft things. And it's going to activate a toolbox called Extrude. And because you highlighted everything here, by default, it'll have the 6 items selected. And, okay, so what's next? What do you do? You really can't see everything because we're looking at it from straight above. What I suggest you do is hover over your view cube and until the cursor kind of turns the upper right-hand corner blue and then click on it. And that's going to give you kind of a 3/4 view. And when you notice that, you'll see this arrow appear. When you grab that arrow and pull that forward, you're going to create a solid body. Now, this is going to be the base of our cube. And because the walls are 3 millimeters, we want to make the base 3 millimeters also. So enter 3, and then hit your enter key. Now, you've noticed that the sketch has disappeared. The reason this happens is once you've lofted something or made a solid body, Fusion's going to assume that you're done with that sketch. We're not completely done, so we need to call it back. And you can do that by going over here to your browser, clicking the triangle, and you'll notice that there's a sketch with the little light bulb turned off next to it. Click on it to turn it back on, and now you have your original sketch. Now, the next thing we're going to need to do is grab the walls here, or the area that kind of represents the walls on our sketch, and pull that through the base in order to get that where we need it to be. But, no matter what I do, I can't really click on it. So what we're going to want to do is similar to what we did with the sketch. We're going to click the triangle next to the bodies. And this body 1 represents this solid object that you just created. We're going to temporarily hide it by turning the little light bulb off. Now we're going to zoom in to the space that represents the walls of our box and click on it. We're going to right click and press pull. Now that we've done that, we're going to go back here and turn our body on, okay? And we're going to talk a little bit about how the system behaves and how Fusion, in order to make the workflow for drawing easier, kind of makes some inferences on what you want it to do. So I now have a sketch that I've selected to press pull through an object. If I grab the handlebars and pull it through, it generates this red box, which really is indicating a cut function. If you look over here, the operation is cut. Because I'm pulling an object through another object, Fusion 360 is inferring that I actually want to cut away the original object. But in this case, I really don't. So what we're going to do is we're going to change this operation from cut to join. The object changes, and then now we can go ahead and enter a distance. So I'm going to click down here to enter a distance, and if we refer back to the paper sketch that we had, we remember that in order to achieve a perfect 50 millimeter cube, the box itself has got to be 47 millimeters tall. So we're going to go ahead and enter that dimension here, 47, and hit your enter key. So that's it. You've made the box for your parts box project. I'm grabbing a hold of the view cube, hovering over the view cube, and then kind of pulling it around to get a different view of it. Okay. Now, the view cube has a little house that will appear when you hover over it, and that's your home isometric view. When I click on that, it'll go to kind of just a standard orientation. And then this will be the orientation, that usually will appear, in your data panel when you have the object saved. The next thing we're going to want to do is create our lid, and we're going to do that a little bit differently. We're not going to select the whole thing. We're really going to select the individual elements of the drawing that we need in order to make the lid. So I'm going to right click on the area that was the walls of our box. We're going to click our press pull command. We're going to grab the handlebar, we're going to pull that up, and we're going to pull that up 3 millimeters, which is the thickness of the lid. Then we're going to repeat the exact thing we just did with the open area. Click on it. We're going to right click, click press pull, and we're going to pull that up, but instead of 3, it's got to be 6. So we end up with a raised boss in a dimension that we want it to be. So we're going to hit 6 and then enter. All right, at this point, we're really done with our original sketch. So we can go ahead and hide it by clicking the sketch itself or the overall set of sketches. And we're going to go ahead and turn that off. Now the sketch is no longer visible. So at this point, we've completed our parts box. But it would be a little bit wasteful to create a lid that has such a solid area here. It doesn't really need to be that big. I mean, that would require infill and filament and all kinds of stuff. So this is a good opportunity to show you a little bit more about sketching. Now, up until now, we've created our sketches based on planes relative to the origin, or that origin point at the very beginning of our drawing. But you can actually create a sketch on any flat surface of your drawing. It could be a sketch on this surface, a sketch on this surface, this surface. I mean, even you could create a sketch on the side of an object if you wanted to have protrusions or something like that coming off of it. But what we're going to want to do here is create a sketch on this surface. So we're going to click our Create Sketch icon, hover over this flat surface, and then click on it. It's going to snap to a top view of that. And what we're going to want to do is use our Offset tool. We're going to click on the outside geometry like we did a little while ago. And we're going to pull that in 3 millimeters, negative 3 millimeters. Hit -3 and enter. Then we're going to click on a space in the center, right click, press pull. We're going to go back to our home view so we can see clearly the arrow and everything like that. We're going to grab that arrow, but instead of pulling it up to create a boss, we're actually going to push it down to cut. Okay, and we actually do want to cut this time. So we're going to go -3 and then hit enter. And now you have a nice little kind of raised boss around the perimeter of the inner perimeter part of your lid that'll engage with your box, but you're not going to have a lot of extra material that you really don't need. Okay? Next, we're going to talk a little bit about our 3D modification tools. Down here, we have the ability to press pull any individual face. So you could click on that and say, hey, I want to make this thing really long. Depending on what you want to do, you can do that. I don't want to do that, so I'm going to go ahead and hit cancel. You have the ability to create a fillet. Now, fillet is just like a round over. So we're going to, let's say, put a 4.5 millimeter fillet here, and then that's going to give you kind of a nice, radius there. And then you can just grab the handlebar and do whatever you want. But in order to have it be kind of concentric, it works out to be about 4.5 millimeters. Okay? If you're not happy with how that looks, you can, click X or escape to get out of it. Another tool you can use is chamfer. You can chamfer again any line or any space anywhere along this. So let's say we'll do the same thing. Instead of radius, you want to put like a facet or a chamfer here. And let's make that 3 millimeters. And that just gives you kind of a flat kind of chamfer face there. And again, you can grab your handlebar to pull it in and out, or really to any ridiculous extent. I mean, obviously you wouldn't want to do that. But you could, for some artistic reason or some other reason, kind of use the chamfer tool to cheat and kind of get you what you wanted, in some other way. We're not going to go ahead and chamfer this. Kind of really like the way that fillet looked. So we're going to activate fillet. and we're going to click on the corners of this drawing. I'm going to grab again the view cube and kind of pull it around so I can see all of them, all the corners. And now that's all selected. And if we're going to do that, we got to do it to the lid too. So we're going to click the lines that kind of are in the same spots on the lid and rotate around there. And once we know we've got all 8 items selected, we're going to enter that 4.5 millimeter radius and hit enter. And there we go. That's kind of a nice looking parts box there. Now you can use the ability to create sketches to do a lot of other things. Like for example, I can click create a sketch. I can select the face of the box. I can use a line to give me something on a center point. If you notice here, just like when you hover over the origin, you get the little square. When you hover over the center of a line, you'll get a little X and a triangle, and that indicates the midpoint. So that's your midpoint snap indicator. You click, you kind of drag along until you get to your origin point, and now you've got something going from the midpoint that's perpendicular, and that's a straight line. And then you can now use that line to find another midpoint and anchor a circle. Let's say that you were going to put some sort of power regulator inside this little parts box, and you wanted to put a 25 millimeter computer fan to cool it off. You would want to put in a 25 millimeter diameter circle. You hit enter to lock that in place. We no longer need the center line, so we can delete it. We can click on the circle, right click, press pull, and then use that handlebar to either extend the boss off of the circle or push it through and actually cut through the entire parts box. So, because obviously if you're going to put a fan here, you want to have a place for the air to go in and you want a place for the air to exit. I'm going to go ahead and click OK and look at this from the front view again. At the same time, you could have also gone online and Googled what the bolt pattern is for a 25 millimeter computer fan, and then use the circular pattern to get yourself 4 holes for the fan to attach. You can also now go around the other side and then put like a grate or some sort of like mesh or something like that over there that you draw in order to prevent your fingers from going in there and hitting the fan blades or something like that. Those are some different things that you can do there. All right, I'm going to switch back to the kind of home isometric view. Now, if you look over here on the left, you see that our browser or our timeline is starting to get populated. You can click the move to the beginning icon where you have nothing and hit play, and it'll actually show you step by step everything that we did to actually draw our cube to this point. And it brings you back to where you are like right now, which is at the beginning. You can also go step by step by clicking the arrows for that, or go to the end. All right. Now, let's say I really like this, but you know what? I really don't want this opening here. So I can grab my slider and kind of go back and back to the point before I put those circles. And let's say I want to get rid of those. So I'm going to right click and I'm going to delete all features after the history marker. I click that and all that stuff goes away. All right. Couple other things I want to show you guys real quick, and then we'll kind of wrap this up. First of all, I want to show you guys how to turn this into an STL file. First, you're going to want to actually save it. I'm going to hit the save icon, and it's going to prompt me to enter a title. And I'm going to name this the intro box. And I'm going to go ahead and click save. And if we toggle this, you'll see that there is now a file called intro box that's been saved here. Okay, now that we have it saved, we can do a couple different things. We can click at the high level on your browser to select everything, right click, and save it as an STL file. Here it'll give us a couple different options. You've already made the selection. You can save it as a binary or ASCII file, and I always save it as a binary. I don't know anybody who's gangster enough to like line edit an ASCII STL file, so we'll just leave it as binary ones and zeros. As far as structure, you can save it as one file so that when you save the STL file and you drop it in a slicer, both objects come in as one thing, or you can have Fusion save it as one file per body. Now it's really up to you. I tend to like to save things as one file per body in order to more easily print things. Like let's say that you print this and then the lid comes out perfect, but somewhere along the box the print ends up failing. It really is not great to have to print another lid even though you have a good one. So by doing one file per body, you'll end up with exactly what you want. So I'm going to click OK. It's going to prompt me to name it. So we have intro box V1. Okay. I'm going to go ahead and change the view of this to details. So I'm going to click save, and now we have that. If I go back to where it was, which I do believe it's in my STLs folder, let's see here. I'm going to change this view to details again. What am I doing? Oh, here we go. Details. These details. We're going to sort it by date, and now we have their intro box, body 1 and body 2 saved. And if we want to, we can now drop these into a slicer, and then they're ready to 3D print. We're going to switch back to Fusion. And so for all intents and purposes, we've completed the requirements of this class. We've drawn a 2D sketch. We've learned about the 2D sketching tools. We've learned about how to make a 2D object into a 3D object. We've learned how to modify the object using some 3D modification tools, and then we've saved it as an STL file. The last thing I want to show you guys is a couple of really interesting things about how you can manipulate drawings. So let's say you wanted to put this together, okay? You're going to want to use a tool called Move. So you'll right-click anywhere in space to activate that. There's a tool here in the marquee menu called Move Copy. It's going to ask you to select what you want to select, and we're going to say it's this, and it'll give you that kind of familiar handlebar arrangement that you had before. But last time we looked at it, it looked just like this. You can only see, from this one plane, the free move icon, which gives you the ability to move around anywhere. You have the arrow icon that will move it exactly on the z-axis or on the x-axis. But if you go back to your isometric home view, you'll see that you can also move things along your y-axis, and then you have the ability to rotate on any of the axes. I'm just going to set that back to 0 because we don't want to rotate that now. Now, if you wanted to do this, you could, let's say you wanted to assemble this box, you wanted to put the lid on it and see how it worked. You could take it, you could flip it around 180 degrees, you could lift it up, you could pull it over, but how would you get this to be exactly on top of the box where you wanted it? Using this particular tool, the best that you could do is really kind of just eyeball it. Now, there's some tricks you could use to really get this to be exactly right, but there's a function, there's some different move types that are available to very quickly and easily get this lid assembled properly. And to do that, you're going to use point to point. So click on a point to point icon, and what it's going to ask you first is, obviously you have something selected already. What is the origin point, or where are we going to start kind of our move from? And I'm going to say I want to use this circle as my origin point. And when I hover over the circle, it's hard to notice, but the very center of the circle ends up being indicated blue, and that actually becomes the origin point. Then the target point, logically, is where do you want this to align to and end up? And we want that to be right here. Now, as you see, there's a little line that's indicating the path that the move's going to take place. And if you moved it somewhere else, you would see that line kind of give you a little bit of a preview of where it was going. All right, so now when I click this, bam, it actually puts it exactly where it's supposed to go. I'm going to go ahead and click OK. And now you see our box is assembled. If you look at it from above, you'll even see that you can see the difference in space between the 3.5 diameter circle in the lid and a 2.9 millimeter diameter cylinder that the threads are actually going to thread into. It's pretty cool. And it's perfectly aligned. If you want to see a little bit more detail about this and how it's kind of all going together, you have the ability to use the inspect function. Inspect gives you the ability to very easily measure something like, hey, is this really a 50 millimeter cube? So we'll click this face here, rotate around the other side, and it'll say, yes, it is actually a 50 millimeter cube. How about the height of it? Did I actually get that right? So we're going to click this to kind of start over again with our measure. Click the top surface, click the bottom surface, and again, it's exactly 50 millimeters. So in every dimension, this is a perfect 50 millimeter cube project box, exactly like we set out to create. All right, now there's another function under the inspect tool that's really nice, and that's called a section analysis. This gives you the ability to create a cutaway. So again, you click the drop down under inspect, select section analysis, and now it's going to ask you what face do you want to kind of start with for your cutaway. And I'm going to say I want this front face of the cube. This plane that you now see represents the cutting area, and as I push it through, it'll actually cut through the object until we reach, let's say, a midpoint of 25 millimeters, which would be the exact center of the box. If I click OK, it now will keep you at that cutaway area. If we go to the front view and zoom in, you'll see that you can observe that 0.5 millimeter gap. Now it looks like a lot, but when you actually print this out, it's actually going to be a tight fit, believe it or not. And then of course there's no gap whatsoever between the lid and the actual wall, which, you know, that's correct also. Okay? There are a lot of interesting things you could do with cutaway. It can give you like the ability to more easily see things inside, like if you wanted to add some fillets in here or draw something on one of these faces and be able to clearly see everything you need. You can toggle your analysis just like all your other ones by turning it on and off. And just like before, you can go to your bodies and you can turn different parts of your bodies on and off in order to get at what you needed. All right, so at this point, everyone should have a box that looks just like this. You know, please respond in your video comments. Tell me what you thought of the class. If there's any topics or if you got any questions, we'll do our best we can about answering that in future videos. I hope you enjoyed the class. Stay tuned to 3dguru.online for more videos about how to use Fusion 360.